and welcome back to this week's Science and Technology News, where we take a look at all of the latest in-depth news that's been breaking around the world. We have a look at some of the most breathtaking scientific breakthroughs, some of the best technological breakthroughs, and as your host, I explain the impact of all of these different things. I said, because as a futurist, I track over 600 emerging technologies, hundreds of different megatrends, up to 50 years out. So, with no further ado, that's it. Let's go and have a look at what news we've actually got. So, this piece of news is an interesting one for a variety of different reasons. Now, traditionally, when we think about artificial intelligences talking to one another, we think quite often that they probably speak in the native language of the people who created them. So, for example, if Americans are creating AI bots, then we think that those AI bots are talking with one another in their own sort of natural language, which would be Americanese. However, over the past sort of 4 to 5 years, we've seen AIs developing their own language to talk to one another because, ironically, they feel that it's a little bit more convenient. But we've now seen a Bulgarian researcher develop a specific AI to AI language protocol called GG-Wave. Now, if you actually go into this particular sort of piece of news, what you'll actually see is you'll see this YouTube video. And it's rather amusing. I mean, it did the rounds on the internet for obvious reasons that you'll see when you watch it. But these two AI bots were trying to negotiate a hotel booking with one another. They started talking together, out loud in English, sort of across devices. And then all of a sudden, they started realizing that they were talking to an AI, or they were talking to other AIs. And they switched to GG-Wave. Now, on the one hand, GG-Wave sounds like the old 1980s modem dial-ups, and you'll sort of be able to hear it. Secondly, it's actually quite easy to hack, so you could actually manipulate this. So there are some security implications of this particular technology being used at scale. But thirdly, and probably what's more interesting than anything else, and I've been seeing this with other artificial intelligence agents around the world, is the fact that these AIs recognized that they were talking to other AI. So that's actually an AI emergent behavior. And we don't necessarily know where that leads, but as artificial intelligence increasingly recognizes that it's talking to another artificial intelligence or engaging with another artificial intelligence, it's likely that it will change its behaviors, what it does, how it does it, etc., which will then likely change some of the outcomes, and that could have a variety of different implications for a variety of different industries, good or bad. So that's a sort of interesting. That's probably one of the more interesting areas to actually watch. Technically, self-aware AIs, if we really kind of want to go down that rabbit hole. Now, next, we've actually got this one. So an artificial intelligence applied to go to an art college in Vienna, and it got in. Now, part of the reason that it got in is it went through the application process, and it actually outperformed a lot of human students that were applying to the same college. But most interestingly, the college admins, when they were actually asked why they enrolled a creative artificial intelligence in a university arts degree program, let's face it, is really for students, human students, they said that there was nothing in the university rules that expressly prevented an artificial intelligence or a non-human attending college. So on the one hand, basically, they thought it would be fun to see what actually happens, and the AI is now attending lectures and actually doing very well. It's actually self-learning, etc., which is just another bonkers thing by itself. But it does actually start raising a sort of broader question of, as we increasingly see AIs capable of zero-shot or few-shot learning, where they can teach themselves new things, what does that really do for the future of education? Do we, for example, have artificial intelligence universities that are just there for AIs? Do we have specific AI learning programs? So at the moment, AIs are trained on huge amounts of sort of big data sets, essentially. So is there a new ecosystem that might form here where an AI via an API could just log into or access a new set of data, maybe via the MCP protocol, which I've talked about before, which is Anthropic's open source protocol, which is increasingly being used by companies like OpenAI, Google, and so on and so forth. And that AI determines that it's going to log in to an AI university because it wants to learn something new, whatever that happens to be, and off we go. So again, kind of a bonkers sort of way of thinking about things, but actually when you start putting it in the context of everything else that's actually going on, it might not be as bonkers as it sounds. So next, we've got a new brain-machine interface. Now, there's nothing necessarily special about the new capabilities of this brain-machine interface. So it's able to translate human thoughts into speech in real time, which is very handy for ALS and locked-in patients, as well as patients basically with sort of neurodegenerative disorders, etc., etc. What is special about this is that it is so small that it fits between the hair follicles on your head. Now, over the past 10 years, I've been tracking brain-machine interfaces, and originally we would put on a huge skull cap, these sort of blue skull caps, or you'd have a computer chip inserted in your brain, aka kind of Elon Musk's Neuralink sort of computer chip. We then saw these brain-machine interfaces getting small enough to pack into a pair of glasses, which eventually those BMIs will probably make their way into Meta's augmented reality glasses that we see basically with companies like Oakley and Ray-Ban. So the real story here is that BMIs have gone from being able to put into a pair of glasses, being 3D printed onto someone's neck so that we can read their emotional state and their brain waves, to being small enough that you're not going to notice them. So the technology is not only getting more performant and capable, it's also getting cheaper and much, much smaller, which inevitably starts nudging it towards some form of actual commercialization, which will freak the regulators out. Now, next we've got Huawei. Now, over in the United States, we're seeing President Trump, as well as other sort of politicians, shall we say, hobble, if not cripple, basically some of the United States science and technology innovation programs, etc., etc. If we think about the IRA Act, etc. Personally, I think that's a mistake. So China is now leading in 38 out of 44 significant general purpose technology, emerging technology categories. What we're seeing with China is over the past number of years, Chinese companies have been prevented from buying advanced American computer chips, like, for example, the Nvidia B100 GPUs, to train their AI models with. So over the past few years, especially, companies like Huawei have invested $1 billion building out specific semiconductor campuses. We've seen companies like Alibaba with their honey badger programs actually developing rather interesting new computer chips and so on and so forth. So even though America has sanctioned the export of advanced semiconductors and computer chips and GPUs to China, China is now starting to actually draw level with the United States in a number of different areas. Okay, so there's actually two sides to this story. So firstly, Huawei's 910C GPU, which is an artificial intelligence accelerator, while it's not as good as Nvidia's B100s, what they've now done is they've now managed to put them into huge clusters. So Huawei's cluster of GPUs can now run at 300 flops compared to 180 flops for a B100. So the tagline there is a group of Huawei AI accelerators is now faster than Nvidia's flagship product. However, while Huawei have been focusing on raw speed, they have not been focusing on energy consumption. So these chips, to get the same level of performance as a B100, are consuming around 3.8 times as much energy. However, inevitably, as the Chinese do, the energy footprint will drop dramatically. Now, when we actually think about Chinese semiconductor competitiveness against, the United States also banned the Dutch company ASML from exporting their advanced lithography machines. And if you click into this particular article, Huawei has also managed to crack what we call EUV, extreme ultraviolet light lithography. Now you can, if you click this link here, you can actually go through to that. So now think of this. Huawei has developed a cluster of AI accelerators that are faster than Nvidia's fastest chips, albeit with dirty energy. Secondly, China, who as a country was originally limited to producing computer chips sort of with 7 nanometer size transistors and above, but couldn't develop semiconductors that were sort of 5 nanometer, 3 nanometer, 2 nanometer to compete with, for example, some of the Apple computer chips, etc., now have an advanced EUV lithography technology, which, even though it's still commercializing, it's still maturing, ultimately means that at some point in the next 1 to 2 years, I can see China spanking America's butt significantly. So unless some of these S&T innovation budgets are increased in the United States, I think basically we're just going to see the world flooded with cheap Chinese computer chips that are really, really good, but they run on Chinese silicon, Chinese software, etc., etc. And in fact, when we actually have a look at President Trump's latest round of trade talks, while the United States wanted access to Chinese rare earths, China wanted President Trump to reinstate the export of advanced semiconductor design software. You start putting all of this together, and the United States will be behind if it's not careful. And we can have a big chat about that. Tell me if I'm wrong. Tell me if I'm right. Let's fast forward 2 years. I think I'm probably going to be in the ballpark. I'm not going to say right, because that's a bit cocky. But based on everything else that I see coming out of the United States, Europe, Asia, as well as China, I think China actually does really well. So next, basically, we're going to go over to Amazon. So Amazon have a humanoid park over in San Francisco. And this humanoid park literally does what it says on the tin. Amazon trains its humanoid robots to go around particular obstacles, do human-like things, basically, and they just train and iterate and so on and so forth. Now, one of Amazon's latest sort of thoughts when it comes to the last mile deliveries, which take up about 78% of the cost of a delivery to your house, when you're buying those Amazon boxes, that's 78% of the cost, is to use something like a Rivian electric van that's being driven by a human delivery driver. Human delivery driver pulls up in your neighborhood, gets out, delivers some packages to your house. But out of the back of this van spring a load of humanoid robots carrying packages, and they run around the neighborhood delivering things. That's it. So you have one human, you have probably up to 8 humanoid robots going off into a neighborhood to deliver packages at a lower cost, faster than we would be able to do it otherwise. So it's an interesting concept. Basically, it also sort of brings sort of science fiction vibes as well, of just humanoid robots springing out of a van delivering stuff. And then you combine that with drones on the top of the delivery van, and things start getting a little bit science fiction like when it comes to, hey, you ordered a toaster off Amazon, congratulations, here it is. They might also actually do a better job of delivering a lot of your fine china and everything else unbroken, so who knows. So next, we've got the American Food and Drug Administration that is apparently leaning very, very heavily into generative artificial intelligence to help them analyze a lot of the new drug approvals and reports, basically, that they've sort of been getting through. So to put it into context, for most category A drugs, a clinical trial report could be up to 1 million pages long. So you can imagine being a human reviewer and someone comes through and says, "Hey, I've got a new report for you." And you say, "Put it on my desk." That's it. And it's not only on your desk, it's literally filling your entire office and everything else. So the FDA say that they've managed to improve the amount of time that it takes to review documentation, including clinical trial reports, by about 30%. But I have actually heard rumblings basically that it's not going as well as people think. That's it. So I'm going to watch this story in a little bit. But ultimately, the faster the FDA can review the documents associated with a new drug or drug trial, the faster they can get them approved or denied. And if they're approved, the faster they can get those new drugs basically into the American healthcare system, where they can be used to save lives. And ultimately, through DARPA and something called the EQUIP project, the FDA is trying to get to the point where once artificial intelligence has developed a new drug, which it can do in about 7 minutes for a variety of reasons in computer simulation, they the ambition is to have a FDA artificial intelligence based system that can approve that drug in real time. So today we've kind of got humans on the loop and humans in the loop when it comes to the drug approval process, but eventually we get to human off the loop. So this is sort of an interesting experiment that the FDA is running, whether it works or not to their satisfaction. Next, we've got BYD and Saudi Arabia. Now, Saudi Arabia is a petro economy, and there's actually been quite a number of tussles between petro economies, so economies that are reliant on oil, and electro economies, so increasingly countries that are reliant on renewable energy. Yeah, so when we talk about the geopolitical situation, there's an interesting sort of tussle going on there. But what I find interesting about this is, on the one hand, you've got Saudi Arabia, which is a heavily oil dependent country that nevertheless is leaning very heavily into the adoption of renewable technologies, as well as the development of new renewable energy technologies like solar cells through KAUST in Riyadh. Um, and they've been buying, in this case, up to 12.5 gigawatts of lithium ion battery packs from BYD. Now, BYD is China's Tesla. That's it, but without the image problem. So think about this now. When you think about business models and so on and so forth, BYD is creating huge numbers or manufacturing huge numbers of electric vehicles. In addition to that, it's also creating huge amounts of lithium ion battery packs, just like Tesla actually wanted to with its gigafactories. It's now selling those battery packs into Saudi Arabia, which is sort of both allied with China, allied with the United States as well. And so there is the increasing opportunity for BYD to take a lot of Tesla's grid scale storage lunch, which then means that Tesla only gets into deeper problems as we see this sort of rolled out. So 12.5 gigawatts of lithium ion batteries, by the way, is a huge amount. There are very, very few companies on the planet that can produce that kind of scale. To put it into context, one Tesla gigafactory in Texas, the ambition was to produce 10 gigawatts worth of lithium ion batteries per year. So this is a massive deal. Tesla have signed some similar deals, but with California, which have been worth multiple billions of dollars. But when you actually have a look at BYD's rise to dominance in the electric vehicle industry, now you start having a look at its sort of ambitions outside of that industry. I think BYD could end up being a global giant, or more of a global giant than it already is. And I've got more news. Actually, well, we might as well talk about that. So, did you know that BYD's factory in China is 50 square miles? That's it. It's bigger than Monaco. It's also next to the port, and BYD are increasingly owning their own ships. So they make The fact they make their cars basically in an increasingly dark automated factory. They drive them 1 kilometer to the port. They then load them onto roll-on, roll-off ferries that they actually own, so cargo ships that they actually own. Um, BYD, when you actually have a look at what else it's doing outside of manufacturing electric vehicles, it's a real giant. It's a huge operation, something quite to see. Now, next, talking about giants. So Microsoft has a market capitalization of about $3 trillion at the moment. It's no secret that ultimately what we want to try to do is we want to try to get some of these large advanced language models that we've been using, that we typically use from the cloud, and put them onto our devices. So put them into Internet of Things devices, put them into our smartphones and everything else. So Microsoft has been very busily working on a 1-bit AI model, which is like a tiny, tiny AI model, basically, that can actually run on a single CPU at the edge of the network. So when we have a look at the development of what we call shallow neural networks, which are rather sophisticated artificial intelligences that require very small amounts of computer memory to actually do what they do at the edge of the network, this is actually a very interesting breakthrough. But it's one that most people will have missed because actually it's also kind of a tad boring. But over the long run, you will start seeing a lot more organizations and companies out there saying, buy the new phone. It has AI embedded within it, not accessible via the cloud. And that means basically that you're going to be able to do things like natural language processing, machine vision processing, etc., at the edge of the network much, much faster with much lower latencies. So the usability of our devices, thanks to sort of innovations like this, will actually become much, much better over time. Now, again, something that I think a lot of people basically just simply won't be paying attention to. One of the emerging technology areas that I do pay attention to is, should we say, clocks. So atomic clocks, nuclear clocks, and everything else. Now, on the one hand, when we actually think about atomic clocks, they are used typically to keep the global GPS satellite networks in sync, the internet in sync. However, we know that artificial intelligence today has an energy problem. It's a real energy hog. If we have a look at the $500 billion American Stargate project, it's estimated that that single data center, as per Eric Schmidt, will consume 10 gigawatts of electricity. Now, to put that into context, that is the equivalent of 10 nuclear power stations worth of electricity. When we have a look at some of the new OpenAI data centers that are being built in Abu Dhabi, those are between 2 gigawatts and 5 gigawatts. So, these data centers typically have up to 300,000 GPUs and so on and so forth. So the long story short is, as we should all know by now, AI factories are getting bigger and bigger and bigger. They are packed full of GPUs up to the rafters, and they are using humongous amounts of energy. Therefore, we've got a lot of researchers around the world that are trying to develop new AIs, new computer chips, and new ways of reducing the amount of energy that artificial intelligence uses. In one research lab's um, sort of uh, purview, the University of Oxford has come up with a new system to reduce AI energy consumption 4,000-fold by creating something called reversible computing that I've talked about before. But back to this one. So enough of that preamble. That's to give you some background. When you are running these massive hyperscale data centers, AIs need to be able to access data on lots and lots of hard drives, lots and lots of computer chips, lots and lots of memory storage, and so on and so forth. So timing matters. So in this particular case, we've actually seen a number of Swiss researchers create a new MEMS clock. So MEMS is a kind of MEMS resistor technology. But this clock, which is really, as all clocks do, there to keep time, improves the synchronization, improves the efficiency of the synchronization of AIs and AI models with the infrastructure that they rely on. So the CPUs, the hard drives, the networking, etc., etc. And so in this particular case, we've managed to find a way to reduce AI energy consumption 300-fold. So MEMS clocks are not a technology that pretty much anybody is going to be paying attention to. But when you start putting new artificial intelligence chips with new sort of energy optimization technologies like AI energy optimization technologies together with this, you do actually start reducing the amount of energy that AI actually uses. And actually, a lot of this could be nearer term rather than further off. So next. Okay. Now, when we actually have a look at payrolls, so I've been doing quite a lot recently with Workday on the future of agentic finance and the CFO. So I've actually got to re-record that session a little bit later because it was a webinar. So that'll pop up on this channel probably in about a week's time. So I'm going to record that keynote presentation again tomorrow so you can all see it. Now, when we think about global payroll, if you're a global company and you have global employees, which they all do, you need to pay them. However, all of those employees live in different countries with different financial systems, different currencies, different payment regulations, and so on and so forth. So it's actually a real headache. Now, increasingly, companies like ADP, the payroll company, are starting to use artificial intelligence to streamline global payments for payroll and to make it easier. That's it. So in this particular case, it's very much a case of I want to send a payment from wherever I am to wherever you are. AI takes care of all of the regulations, all of the compliance autonomously, and you just get paid. Now, the reason why this is significant is when we actually have a look at the development of RegTech, which is regulation technology, but for entrepreneurs and startups. Startups, that'd be a funny one. Compliance and regulation today typically costs the vast majority of organizations 10% of their revenues. So one of the other areas that I watch is the use of AI in GRC, so governance, regulation, and compliance. And we are making some really interesting headways in using artificial intelligence to either semi-automate or fully automate regulatory burden. And anyone basically that works in law, anyone that works in compliance basically will know it's a complete headache, especially as we see tariff changes coming through so quickly. Next one. So Google, I've talked about agentic commerce before. So actually last week I was in Dusseldorf. Basically I was at Digital Beat. We had about 3,000 people in the room. And I was talking about the future of agentic commerce. So again, that video, which I get this week, should actually go onto the YouTube channel probably again this week. So Google has been releasing artificial intelligence agents that do your shopping for you. So at the moment, you might go to multiple e-commerce websites, you have a look at them all, and then you decide what you want to buy from which e-commerce site, and you go off and buy it. Agentic commerce streamlines all of that. So you simply say, for example, to a Google AI agent, I want to buy a white shirt. Now, it should know you intimately enough because these AIs have over 165,000 data points on you. And it kind of says, well, I've got a couple of shirts here for you. You pick one shirt and it goes off and buys it. But it might not buy it from Walmart. It might buy it, for example, from Amazon, or it might buy it from Alibaba. But the point is, the artificial intelligent agent buys everything for you. And it just goes, I bought it for you. So you as a human never ever get to the retailer's checkout page. In fact, you aren't even really sure where the AI has bought that white shirt from. So agentic commerce is the fundamental and absolute disruption of traditional retail and e-commerce. Now, if you imagine the amount of money that retailers, like Patagonia, for example, or North Face, spend on marketing their products through social media and other channels, yeah, if you imagine how much money they spend on SEO optimization, etc., etc., increasingly they're going to have to redirect that spend to a new Google platform. We're seeing Visa doing this, we're seeing Amazon doing this as well. So ad spend is going to change. Um, and when we think about agentic commerce, at the moment, these companies are marketing to you. So I'm marketing my white shirt from, say, Thomas Pink in Pall Mall in London directly to you because you are the target demographic for this particular product. But if AI agents, which are essentially robo customers, are now identifying, so discovering the product and buying it on your behalf, does a company like Thomas Pink in London pay TikTok to show me their advert? Or do they pay Google to get Google's AI to recommend that product to me, like they sort of do at the moment, and then automatically buy it? So we see with agentic commerce, everything about the retail industry changes. The payment layer, the checkout, everything. So this is a very, very big space to watch. And actually in September, I'm going to be giving a keynote basically with WorldPay on the future of agentic commerce. So stay tuned for that one. Hopefully they record that. And then last one, but not least, so we've actually seen an undersea Ukrainian biomimic drone shoot down an advanced Russian Sukhoi fighter jet. Now, this is sort of interesting because it signals a whole new direction for the future of warfare. So we know about conventional drones flying over Ukrainian and Russian airspace to go and bomb the crap out of each other. However, this is the first example of a loitering subsurface subsea drone that was armed with missiles being able to take out an advanced fourth and fifth generation fighter jet. And when we have a look at what DARPA have been doing, so DARPA are the bleeding edge research arm of the United States military. They're actually leaning into these subsea loitering drones as well. They've got something called manta ray, which literally looks like a manta ray. And then elsewhere, talking about biomimic-based drones. So these are drones that mimic actual animals. Since we're on the topic, China has been developing new kinds of aerial drones that look like and fly like birds. So from a military perspective, you sort of think, right, is that a DJI drone coming at me? You look at the radar signature, you look at everything to do with that signature, and you sort of think, no, it's a flock of starlings. And actually, it's a flock or a swarm of Chinese drones that's coming to bomb the crap out of you. And that's it. So on that very, very happy note, if you do actually need a keynote speaker, if you want someone to talk at an event basically that you're holding, or a workshop, or a company boardroom session, those are very, very exciting, about the future, basically in terms of, what's here, what's coming, why should we care, etc., etc., what's next, then just give me a bell. So you know where I am. You found the YouTube channel. Don't pretend that you didn't because you're watching this. And I hope you enjoyed that news. I will be back very shortly, basically with the next one. Take care. Goodbye.